There is also another method, heating in the absence of air. In the absence of air, then that we call as pyrolysis. Then it is called as pyrolysis. That process we call it as pyrolysis. So if you do the pyrolysis, the pyrolysis will lead to the liquid products. The pyrolysis will lead to the liquid products. So if you take the coal and heat in the absence of air, you will get a liquid product which will contain hydrocarbons, which is similar to the hydrocarbons, which is similar to the crude oil, but properties are different. If you take the coal particle, if you heat it to very high temperatures like 1000 degrees centigrade or 39 degrees centigrade, in the absence of air, the coal will be converted to a liquid-like product. That liquid will have the similar characteristics of the crude oil. However, the carbon number, the molecular structure of the crude oil and this liquid-like product produced from the pyrolysis are slightly different. But in theory, both are similar. So, if you take this coal, and heat it, what happens? If let's say you are doing the rapid heating, what happens? Rapid heating. If you do the rapid heating, what happens is that when you do the rapid heating, what happens is that thermal decomposition happens. So what is mean by thermal decomposition? Wherever there is a covalent bond, that will be broken. Wherever during thermal decomposition, the covalent bond between the molecule will be broken. So we have very high molecular weight, very long structured, we have the high molecular weight, complete cyclic components are there. These cyclic components are broken down to smaller components. Let's say this is broken into smaller components. So then we will have a single cyclic components with phenols, and we can also have the CH4. It can be broken into very small particles, and it can also be broken down into small components. So during this thermal decomposition, this covalent bond will be broken and produces the low molecular weight hydrocarbons, and will also produce nitrogen based components. It will also produce sulfur based components, and will also produce many other components. So during this thermal decomposition, it will be broken down into small components. If you further heat it, then they will become the volatile components. Completely volatile components. Then finally, you will get to see carbon monoxide and hydrogen, and you will see many other components. So basically what we are doing is we are heating it. When you rapidly heat it, the covalent bond between these chains will be broken down, and they will be broken down to small molecules. Then if you heat it further, they will become the volatile components. If you heat it further, that will be converted to the syngas. So these are the typical reactions takes place in the coal gasification. So here we can do the gasification two ways. We can do the gasification we can do the gasification or in the presence of steam, and we can also do the gasification with the, so we can convert with the presence of oxygen. We can do the gasification in the presence with help of steam. We can also do the gasification with help of the oxygen. Now one difference is that, see, these two reactions takes place when you use steam. These two reactions takes place when you use steam. So if you use steam, carbon reacts with steam and converted to carbon monoxide and hydrogen, and this is endothermic reaction. Whereas also the carbon reacts with carbon dioxide and produces carbon monoxide, and this is also an endothermic reaction. If we do coal gasification in the presence of oxygen, the carbon reacts with oxygen, produces carbon monoxide, and carbon reacts with oxygen, produces CO2. Then it can also produce methane. It also produces methane, and these are all exothermic reaction. Right? So we have homogeneous reactions which produces the carbon monoxide can be converted further to CO2, and carbon monoxide can react with water and can also produce CO2. Although we don't want these reactions to happen, still the carbon monoxide can react with water and form CO2, and carbon monoxide can react with oxygen and form the CO2. So if we do reforming, if you do gasification with help of steam, we need to give energy. If we do the gasification with help of steam, we need to provide energy, because this is endothermic reaction. Gasification with steam, we need to provide energy. Energy needs to be supplied. Because they are endothermic reaction. Whereas gasification in the presence of oxygen, exothermic reaction, energy will be produced. Gasification with air releases energy produced. But one problem happens is that when you do the gasification in the presence of air, CO2, more amount of CO2 will be generated. In this process, more amount of CO2 will be generated than the gasification with steam. So what they do is, here we'll get less CO2 and here we get more CO2. This is energy required and this is energy supplied. But if you want to make a process, that is autothermal, that is we don't need to provide any net energy. If you want to make gasification process autothermal, that is you don't need to supply process, but at the same time we wanted to produce less CO2. So to make the process autothermal, that is without supplying any additional energy or external energy, what they do is they make the process autothermal. By how do they make this autothermal? They will do the gasification with steam and air simultaneously. So whatever energy released in the gasification with air, that will be utilized for the gasification with the steam. That way we can minimize the CO2 formation and we can get the high quality syngas. At the same time, you don't need to supply external we don't need to have any external heat exchangers. We don't need to have any external heat exchangers. So that is called autothermal. If you do steam, we need to provide energy. If you do gasification with air, we need to recover the energy. We have to cool it. We have to remove the energy. But if you combine both gasification with steam and air simultaneously, that is called autothermal process. So whatever energy produced in the cold gasification in the presence of oxygen will be utilized for the energy required for the cold gasification in the presence of steam. So that is the common processes are being used in the current industries autothermal process. So that's why here we have given all the reactions. That's why we have given all the reactions. The coal gasification in the presence of oxygen and coal gasification in the presence of steam. So simultaneously both reaction takes place, and if you join all together, still we have the net amount of energy is produced. That net amount of energy is produced will be used for the producing steam. That net, see, if we add all the energies together, we have still net amount of energy will be exothermic. Net will be energy produced. Whatever energy produced, that will be used for the producing steam. That way you can make almost, you can cut down the additional energy or net energy, external energy supplied. So how do you do the gasification? How do we do the gasification in a commercial gasification? Now, as I said, in the gasification, the coal particle needs to be heated rapidly. This is coal particle needs to be heated rapidly. Rapid heating, maybe it's a better word. Rapid heating. So when you take the coal particle, if you do the rapid heating, what we are going to get? Syngas, and unconverted coal particle will be formed as char. Ungasified coal particle will be converted as a char. Unconverted coal particle will be converted as a char. So if you wanted to heat it rapidly, definitely we need high surface area. Then only we can heat a particle very quick manner. So we have three different types of reactors for the coal gasification. For that matter, any other gasification of biomass or gasification of plastics. Nowadays people are using plastics to convert syngas and chemicals. So exactly same method what we are discussing will also be, all the concepts are similar. Whatever if you take which is source of carbon, hydrogen, oxygen, if it is in the solid particle, if you want to produce syngas or any other chemicals, whatever discussion we are doing today, same thing will be applicable. So whatever discussion we are doing, the same thing applicable, whether you do the gasification of biomass, or when you want to do the gasification of plastics, any waste, agricultural waste, all the waste, same principles we use to produce syngas. So we have three different types of reactors. One is called moving bed reactor. That is the one method. Another method is we can use fluidized bed reactor. We can use fluidized bed reactors. We have third one called entrained flow reactor. So first let us see what is this moving bed reactor looks like. The name suggests that the coal particles will move as a bed. The coal particles are moving as a bed. So we have a reactor. So this is a reactor. In this reactor, so we have a feed inlet. And this is This is the feed inlet, and here the coal particles all are fed from the top, all are fed from the top, and is all these particles move as a bed. Bed means a bunch of particles are just flowing down, like we have seen packed bed, a bunch of particles. This is a bed, and the bed tend to move downwards. The bed tend to move downwards. From the bottom, from the bottom, from the bottom, steam and air will be introduced. Steam and air will be introduced. So let's say some of the particles which already entered, some of the particles which is entered, like the bed is moving down, and here whatever particles I am drawing in the blue color, they are gasified. They are in contact with the steam and air. They are in contact with the steam and air. They will contact with the steam and air. So this is the reactor, and here we have the. So here we have like a small mesh kind of thing, and through this mesh, whatever unconverted char particles, very fine particles will be fell down, and whatever unconverted coal will be goes out. So as this steam and air which flows over, what happens is that, as I said, finally as steam and air moves over, first of all combustion of the coal particles will happen, then that will release some heat. That heat will be utilized by the steam and oxygen to increase the temperature of the coal particles to very high, and as soon as the coal particles reach to very, very high temperature, this gasification reactions what I showed in the previous slide, that will happen, and as it goes up, you will see as the gasification takes place, and these are the gas, doesn't go this side. So this is sealed, one side sealed, and one side there will be opening. And whatever gas is produced, that will be going through this one. So this will be basically since you're gasifying the coal particle, and whatever reactions I showed in the previous slide, those reactions will happen. Then you will have the gas. This gas will contain syngas, but it will also contain CO, H2 and CO2, and we will also have the H2S. Because some of the sulfur components are there, and we will also have the mercaptans, and many other impurities will happen. But predominantly CO and H2. If you see the concentration, it will be almost 81 to 85%. 81 to 85% of the syngas will be there. 85% to 80% syngas will be there. Not, I think above, but depends on the coal. This depends on the purity of the coal. Suppose if you take the coal from some of the reserves in India, it will have very high sulfur content. Then we will have the purity of the syngas will be lower. But if you take some of the coal reserves based in Europe and Australia, then they have the very, very less sulfur. So at the time you can get the quality of the syngas could be more than 95% also. So this syngas which is produced, you can see there is a lot of free space, and there is a smaller bed. There is a bed, and this gas will be circulated over this bed. This gas will be circulated. This is not internal, okay? This is only external. This gas will move over this bed and comes out like this. The gas will move over the bed, comes out like this. And this syngas is very hot because we are raising the temperature to almost above 1000 degrees centigrade, and these are the feed particle. These are the feed particle. These are the cold feed particle. So when this gas is flow over this bed, when this gas is flow over bed externally, then what will happen? Heat transfer from the syngas to cold particle will takes place. Heat transfer from the syngas to the cold particle will be takes place. That way they will do the preheating. They will do the preheating of these particles. So these preheated particles, I am just changing color. The preheated particles will enter into the bottom bed. This is the red particles are preheated, and after preheating, these red particles will be converted to the, let's say, the green particles. The green particles are preheated particles, and the preheated particles comes down and comes in contact with steam and air, where gasification will takes place. Where the gasification will takes place. After the gasification, whatever unconverted particle, they will taken as a char. They will taken as a char. And if something is very, very fine, the fine particles are collected, and that can be used as a slag. So that way, the moving bed reactor gasification will be working. That way, the moving bed gasification reactor will be working. So here, this way we get the syngas. We'll get the syngas or whatever gas, syngas. But this is impure. This is impure because it contains CO2, mercaptans, H2S, and any other component. And this gas will be undergoes to the gas cleaning process. Gas cleaning process means where they will remove the CO2 by adsorbing onto the gas. CO2 can be adsorbed onto the some of the base components like NaOH, KOH, and other thing. Just now, last week we have done the mass transfer experiment. There we have seen the offset analysis, how we remove the CO2. So similar gas cleaning process will be done. Mercaptans also will be removed. That you will learn in more detail from the next part, that is petrol refinery engineering part. You will learn more details about how to do the hydro treating, how do you remove this H2S and other components. So after doing this gas cleaning, we will get the clean syngas with almost 99% purity. Which will almost have the 99% purity. So this is the moving bed reactor. One of the significant advantages of moving bed reactor is that we are able to utilize the heat produced by the syngas for the preheating. So net energy demand is less. Net energy demand for the preheating also less, or more energy is utilized properly. So more energy saving process. This is more energy saving process compared to the other two process. But one big problem with the moving bed reactor is that since the particles are moving like a bed, efficient gasification will not take place. Rather, what happens when you heat it, the cold particle tend to join together. Cold particle tend to join together and can form like a thick slag. That will be reduces the gasification potential. That reduces the gasification ability. I hope you're able to understand. If anyone have any questions here, please ask me. Right, no questions, that is good. So another type of reactor is fluidized bed reactor. As the name suggested that here the cold particles are fluidized. So we have again reactor like a cylindrical vessel, and here from the bottom we are introducing steam and air, and here the bottom of the reactor, and here from the top, like little higher from this one, we will feed coal particles, Sometimes they feed from bottom, sometimes they feed from the top in a counter-current manner. Here we have the, again we have the same mesh like thing, and we have an outlet for the char particle to go. And here, so here what happens, what happens is that, so the particles comes down and gets fluidized. In this case, the air and steam velocity should be higher. So that the particles are fluidized. One of the advantages of fluidization is that uniform mixing of particles and steam and air will take place. Uniform mixing of steam, air and coal particles will take place. That way there is more. See, when the steam and air enters, there is a contact. The more contact between particles will take place, and as the particles moves, the mixing, so energy, if uniform mixing or uniform temperature across the fluidized bed can be achieved. As the particles are moving. Since particles are moving from one point to another point, mixing will take place. Whenever you have the proper mixing, the uniform temperature, uniform concentration, uniform reaction will take place. That is the advantage with the fluidized bed reactors. So these particles will go, and the particles after gasification, some of the particles may fall down, and some of the particles will be carried along with the gas. Here we have the gas and we have the particles. So these particles are unconverted coal particles, which are char particles, and we have to separate them. How do we separate them? How do we separate these particles from the gas? Any suggestion from the students? So what process we need to keep here? We have gas, we have particles, and we want to separate these particles from the gas. Maybe you're answering right, but a lot of background noise, so difficult to hear. I think this is, so we will use cyclone separator. Maybe you are telling the same answer, but I could not hear. So here we use cyclone separator. So this cyclone separator takes out the syngas, impure syngas, and we have the char particles. This is the char particles removed. And this syngas again undergoes to the gas cleaning process and get the pure syngas of 99%. 99% purity syngas we can produce. So this is another reactor, another gasification reactor, that is fluidized bed reactor. The third one is entrained flow reactor. So this is the typical cross section of entrained flow reactor. Here we have the screw conveyor. So this is the screw conveyor. So the coal particles are fed through the screw conveyor. One of the advantages of the screw conveyor is that we can discharge a uniform loading of particles with a known rate. So the particles comes here, and here they introduce steam and air are introduced, and these particles are fluidized. Along with the help of the steam and air, as the particles are fluidized, as the particles are fluidized, the gasification will take place. The coal particles are converted to syngas, and here since we are analyzing the cross section, the velocity of this steam and air with coal particle mixes will be reducing. When the velocities, since the velocities of the steam and air is reducing, the particles terminal settling velocity also will reduce. The particle terminal settling velocity will also reduce. That way, by the time it reaches the midsection, these unconverted particles can settle down. So here we are using Venturi type cross section. So we are enlarging the cross section. As it enlarging, the velocity will reduce. When the velocity reduces, the particle terminal settling velocity also reduces. So after the gasification, whatever charged particles are there, they can be settled down. They can easily do the settling. So this way, the charged particles are settled. And here, whatever gas produced, that will be leave out from this reactor. Whatever syngas produced, that will leave out from the reactor. Again, this is impure syngas, and those impurities will be removed at the gas clearing process. So one side they do this one. Similarly, other side also we have the screw conveyor. This is the screw conveyor, and the coal particles are fed with help of the screw conveyor. And again, they will introduce steam and air from this side. Steam and air introduced. So this way, same phenomena takes place. And the charged particles are settled here. And that will get the charged particles out. This is the entrained flow. Entrained and fluidization is similar phenomena. So only thing is in the fluidization, we won't reduce the velocity, we don't change the cross section, but here we change the cross section. Now if you want to do the entrained flow reactor, it gives the very good conversion, very high conversion compared to the other two reactor, high conversion of coal compared to the other two reactor. Here, since we're using the steam and air, the particle size should be much more smaller. Because we want to do the entrainment. The particle size utilized here is much smaller than other two type of reactors. So these are the three types of reactors used in the coal gasification. So this way we can convert coal to syngas. Now what is the use of this syngas? So syngas is carbon monoxide and hydrogen. How do we do this? The syngas can be utilized into three ways. One is for the power generation, also to produce synthetic natural gas. So another use of this one, we can use syngas to produce hydrogen. What is the use of hydrogen? Fuel cells. We can use this hydrogen for the fuel cells, and we can also use in many hydrogenation reactions. For many hydrogenation reactions, we need hydrogen. So we can use many hydrogenation reactions in the petroleum refining operations. We can use it. Another use of syngas is that we can produce chemicals like methanol, and from methanol you can produce many other components. So we will use Fischer-Tropsch synthesis. We can convert syngas to chemicals using the Fischer-Tropsch synthesis reaction. If you want to convert syngas to hydrogen, we will use water gas shift reaction. We will use water gas shift reaction to produce hydrogen from the syngas. And if you want to do the power generation, we will do the simple oxidation or direct oxidation of the syngas to produce the power. So we'll quickly see these steps, these methods. And this is the catalytic gasification method to produce synthetic natural gas. Synthetic natural gas. So so we have the coal feed, just the coal preparation. We'll add some catalyst, copper catalyst. Then we'll add steam and we'll do the gasification. After the gasification, we'll go to the gas cleaning process. After the gas cleaning process, we have the pure syngas, and this pure syngas is applied as synthetic natural gas. Like, you know, we have, let's say we have we have natural gas, that is methane, and we can oxidize it to produce energy. So we can also use the syngas, we can oxidize it and produce energy. So different companies develop this process, like one of the ExxonMobil, this company, very popular, and to produce this catalytic gasification, and they have used for certain years also. But after they discovered shale gas, after they discovered the shale gas reserves, this process becomes unused, because, you know, shale gas is much cheap and much pure quality of methane can be produced. So they could not do this coal catalytic gasification of coal to produce synthetic natural gas. This is the method to produce electricity. See, I just explained this gasification. This is the entrained gasifier. Just methods we discussed, and you know, we have the cyclone and we have the gas cleaning, and here we got the clean gas. Let's say we got the clean gas here. Till this one, what we discussed so far is same. This one, whatever we discussed so far just now, that is the same, so you don't worry about it. So clean gas comes, right? The clean gas come from here, and in this, since the syngas will be very hot, since the syngas coming out from this reactor is very hot, that is about 1000 degrees centigrade, you know, we can also use to produce steam. So just passing, using the simple heat exchanger, they will send the water, boiler feed water, and they will get the steam. So the cool clean gas comes at the bottom, and the hot syngas is utilized for the steam. That steam is supplied to the turbine, and that rotates the generator, that used to rotate the motor in the generator, and from generator we get the electricity. Now we get the cold syngas. In the combustion, we will react with oxygen that produces a lot of heat or high pressure gases. That high pressure gas is sent to turbine, and the turbine rotates the generator, again produces the electricity. That way, most of the power plants operates this way. So they don't use often the combustion, they do often gasification. That way you can minimize the carbon dioxide production, and also we can make it the efficient electricity generation. This way we can use the syngas to produce electricity. Now to produce, to convert syngas to hydrogen, so CO plus H2 already is there, and we wanted to utilize the CO to produce H2. So we do the water gas shift reaction. So we'll react with water, and the CO reacts with water and converts CO to an H2. So that whatever H2 in the syngas and whatever H2 produced here, the both will be used as hydrogen production, and the CO2 will be recovered. With help of some of the solvents like NaOH, KOH, and many other methods are there. So one of the important thing I wanted to highlight, if you want to use this water gas shift reaction, again we need catalyst. And here, if you see the thermodynamics, the rate constant and will be very high at low temperatures, So if you wanted to convert syngas to hydrogen, we need to operate at low temperature. low temperature. So although this is catalytic reaction and catalyst needs to be activated and catalyst activation will be done at high temperature, still this hydrogen generation is possible because in the modern days we people have generated catalysts that can be active even at low temperature also. They are active even at the low temperature also. That's why it is possible to produce, it is possible to convert this syngas to hydrogen even at the low temperature. So this is very simple process. We have the syngas after the either from the gasification reactor, they will be supplied to a reactor. They will be supplied to a reactor where catalyst is there. So syngas will be passed over this catalyst, and here we get the CO2 and hydrogen, and it undergoes to the CO2 separator. It will go to the CO separator, and after the CO2 separation, we get the hydrogen. This hydrogen is utilized by the fuel cells, energy applications. And Government of India has focused a lot in the recent days to produce hydrogen-based fuels. The last one is production of methanol from the syngas. So again, if you use copper catalyst, you know, carbon monoxide reacts with hydrogen, which is only in the syngas we have carbon monoxide and hydrogen, so both reacts and produce methanol. And whatever CO2 is there, that will also react with hydrogen, also produce methanol. So these are the thermodynamics. In olden days, when we need to operate at very high temperature for making the catalyst to be active, they used to operate at 300 bar pressure. Because at 300 bar pressure, we can operate the reactor at higher than 600 degrees centigrade. So we need high temperatures for the catalyst to be active. But in the modern days, people able to produce catalysts are active even at the low temperature, so they are able to operate between 50 to 100 bar pressure. And we could get almost 90% conversion, almost 80 to 90% conversion, or about 70% conversion. That way they are able to produce methanol. From methanol, we can produce many components. From methanol, we can produce components. If react with amines, we'll get methylamines. If react with so many other components, acetic acid, methyl formate, methyl chloride, formaldehyde, this way we can produce many chemicals. We can convert syngas to methanol. From methanol, we can produce many chemicals. So that's what I mentioned here. From coal syngas, we can produce power generation, synthetic natural gas, we can produce hydrogen, and we can produce chemicals by converting syngas to methanol, from methanol to many other components with help of the Fischer-Tropsch synthesis reaction. So whatever discussion we did, as I said, we can do same thing for biomass, we can do same for the plastic, and we can also do same thing for the food waste or agricultural waste, food waste and municipal waste, food well waste, agricultural waste. All these things can be done the same gasification, same thing. So with that I conclude here, and if you have any questions you may ask me. I hope it given you good idea on the gasification process. So if you have any questions you may ask me, otherwise we'll end up this one. And I'll again remind you that next Wednesday we have test, and I'm conducting the test using the Moodle platform. And this time I'm conducting the test using the Moodle platform. So I will send the details, and I'm sure you also have the experience of writing the test in the Moodles. So thank you so much, and have a great day, and see you on Wednesday. Yeah.
So is it possible?
Is it possible?
Is it possible to conduct the test other platforms of Moodle?
No, I want to conduct only using Moodle. What is the problem with Moodle?
So because for those who are not in campus Moodle, sometimes can be problematic.
Yeah, if someone has really problem, I will conduct Viva for them.
Okay, sir.
Yeah. Any other questions about the test or about today's class or previous classes? Okay, thank you and see you day after tomorrow.